Okay. So let's go ahead and start off by, I want to talk about system recovery. Okay, now system recovery is basically what the whole EPA thing is about. Okay, we can't just dump refrigerants to the air. We have to recover refrigerants. Okay, there's a lot of chemicals in refrigerants. There's a lot of things in them that affect the ozone layer, have global warming potential, and so on and so forth. So we really have to be a little bit cautious about what we do with recoveries. Every recovery machine, that's the equipment you actually connect to the system to recover the refrigerant, is different. Okay, it's very important that you read the operating manual for the machine you're using. You actually can damage the machine and you can get hurt if you don't operate these machines properly. We're talking extremely high pressures. We're talking pressures that can actually burst lines and blow out pieces of equipment if you're not doing this properly. Safety glasses must be worn at all times. And I even in the field, you know, we joke about people not wearing safety glasses and stuff like that when we're out in the field. I wear safety glasses when I'm working with recovery machines. You just never know what's going to happen and what's going to go on. Okay, 3 R's, and this is on your EPA exam. The 3 R's of protecting the environment are recovery, recycling, and reclamation. You're going to hear me say that again tomorrow when we start talking about EPA. But the bottom line is we're talking about recovery, recycling, and reclamation. Okay. Refrigerant should be recovered from the system as a liquid. Okay, so if I'm attaching a recovery machine to a system and I want to recover it as a liquid, what side of the system am I attaching this machine to?
Low side.
Hi.
Okay, well, the first option, the low side, you took a 50-50 chance. Unfortunately, it was the wrong 50. So where am I going to get liquid?
Liquid line.
Out of the liquid line, so on the high side. Okay, you can recover as a vapor, but it's going to take considerably longer. It's important that the refrigeration hoses should be of good quality and have good sealing gaskets. We check them every once in a while. Anybody know the easiest way to check your refrigerant hoses for leaks? These are your gauge hoses. Anybody want to guess the easiest way to check them for leaks?
Charge them with like 5 pounds of nitrogen and let them sit.
How about putting 200 psi of nitrogen into it and dumping just the hoses in a bucket of water? You're going to find the leak very fast when you see the bubbles. The other way you can check refrigerant hoses for leaks is actually attach it to a vacuum pump. If your vacuum pump can't pull and hold 500 microns on your gauge hoses, they're leaking. Okay? Easiest ways to do it. 2 easy ways to do it. Put nitrogen in it with a bucket of water. Okay, and you don't dump the gauges in the water, just the hoses. Or put them under vacuum. If they can't pull and hold a vacuum, you have a problem. Now, some of the older recovery units and some of the large truck-mounted one may need a warm-up period of 10 minutes. Okay, again, read the directions because normally we don't have to, the newer recovery equipment, we don't have to warm up anymore. Now, recovery is defined by the EPA is to remove refrigerant in any condition from a system and store it in an external container without testing or processing it in any ways. It's exactly that. Recovery is to remove refrigerant in any condition from a system and store it in an external container without testing or processing it in any way. Refrigerant recovery can be reused in the same system. It can also be reused in a different system if owned by the same owner. So according to this statement here, which again you're going to hear me talk about with the EPA series of slides and stuff that we're starting tomorrow, can you recover refrigerant from, let's say, an R22 system that you're replacing with an R410A system, and can you use it at another person's house that might have a leak on their system?
No.
Oh,
No.
Absolutely not. Okay, again, you cannot use it with a system with a different owner. You can only use it systems with the same owner. The reason they're doing this, the reason this law was put into place, when the EPA guidelines first came out, when the requirements first came out, people were recovering refrigerant from one person's house and then reselling it at highly inflated prices to another person down the road or another customer. So basically, refrigerant is owned by the person who owns the equipment. They have to have you to help dispose of it according to the law, but it is owned by the person who owns the equipment. Per the EPA, refrigerant that has been recovered cannot be sold to another customer unless it meets new refrigerant specifications. Can't do it.
I have a question, Chris.
Yeah.
So let's say somebody's got a system that's R22 already, and they have unused refrigerant that they've purchased that's still in its container, new, and they want to switch their system out to a newer system that uses like R134A. Can you? And they want to give you this old refrigerant they have that's never been used. Can you reuse that again, or because they've already?
If it's still in the original container, okay, we call it virgin refrigerant. Okay, in other words, if it's still in its original shipping container, okay, and hasn't been used, yeah, I feel that fall. Again, there's a gray area here, but I feel that falls under new unused refrigerant.
Okay.
Okay, if it's out of the system, in other words, if I've recovered it from their unit, the law,
you can't use it. Yeah,
I can't use it.
But if it's brand new, unopened, in the original packaging, it's reusable anywhere.
Yeah, it's considered virgin refrigerant. And by the way, since a bottle of refrigerant these days is costing about $600 for R22, that's an awfully nice homeowner. So, any other questions on that? No one's going to ask me what ARI 700 is?
Yeah, what is it?
Okay, glad you asked. ARI 700 is the American Refrigeration Institute. Okay, they set all the guidelines for what the chemical makeup, what the cleanliness, and everything else is for new refrigerants. Okay, and again, the new refrigerants, when you read the manuals, when you read the book, it's considered virgin refrigerant. Okay, so ARI 700 is the guidelines for new refrigerants. Okay, recycling. Remember, our 3 R's were recovery, recycling, and reclamation. Recycling refrigerant is defined as to clean the refrigerant by oil separation and single or multiple passes through devices such as replaceable core filter dryers. The filter dryer reduces moisture, removes acid, and removes particulate matter. Recycling means to clean up refrigerant. Now, recycling again comes into the idea that I can bring the refrigerant to a more usable manner. Okay, you mute somebody there. So recycling is cleaning up the refrigerant. Now, it doesn't bring it to those ARI 700, so even if I recycle and clean up the refrigerant, I really can't sell it to another person. Okay, because it doesn't meet the requirements. Okay, to reclaim the refrigerant. Okay, we're processing the refrigerant to new product specification. Okay, and this could include distillation, which removes water and other chemicals. Reclamation requires a chemical analysis of the refrigerant. The refrigerant is processed to new refrigerant standards. Refrigerant that is reclaimed can be sold without excise taxes. Okay, this is an incentive to save and reclaim old refrigerant. Reclaimed refrigerant can be resold. Now, based on this slide and the previous slide, can you reclaim refrigerant, let's say at your contractor's shop or in the back of your van? Can you reclaim refrigerant?
No.
No. Okay, it requires chemical analysis. This is done in a lab. This is done in a factory where this is all they do. Any questions on the 3 R's? Recovery, recycle, and reclamation.
So what you're telling us basically is that if you take refrigerant out of a system, it is pretty much useless besides use in that system.
Besides used in a system that is owned by the same customer.
Right. So what do they have, like pickup spots for?
Oh, absolutely. Your supply house.
Oh, okay.
Yeah, your supply house. For example, on the campuses, you know, we have those, I don't know if you've all seen them yet, some of the first-term students may not have. We have all those recovery cylinders. They're the ones with the yellow and gray tanks that we use for recovery. Okay? About every couple years, I have the supply houses come in and pick it up and swap the tanks out.
I actually thought something was interesting because we were talking to the supply house from York on the phone, and apparently I think they wanted to charge us to take that old reclaimer.
Oh, they absolutely do.
Yeah.
Yes, they charge.
Ouch.
It's like reclaimed mineral oil.
What?
It's very similar to the reclaimed mineral oil business. They charge garages to take your mineral oil, and then they recycle it the same way.
Yeah, same idea, and it gets even worse on the charge, and I think I talk about it in one of my slides today, but it gets even worse when the refrigerant is mixed. Okay, if they get a tank that's labeled like 409A or R22, and they do a test on it back in the factory where they reclaim it, okay, I get a really great additional charge added onto the bill if they find that there's mixed refrigerant in it, okay, which is always a possibility considering we use it for learning. That's why we're sort of picky about labeling these tanks. I mean, and the fee can be very, very high for mixed refrigerant because there's nothing they can do with it. They have to incinerate it, and that's a whole process on its own. Every one of those tanks has a serial number on it. Those serial numbers are recorded when they're picked up so they know exactly where the mixed refrigerant came from. So there's a lot of money involved in the recovery and reclamation or destruction of the refrigerant. So there are a few recovery techniques which I do need you folks to be aware of, okay? Active recovery uses a dedicated compressor in the recovery machine to move the refrigerant. Now, this is primarily what everybody in the industry has gone to, okay, is active recovery. We use a recovery machine that has a compressor to move the refrigerant. It can be done on a system with a bad or missing compressor. In other words, it doesn't rely on the actual refrigeration or air conditioning system's compressor. Okay, active recovery relies on an outside machine with an outside compressor. Passive recovery is also called system-dependent compressor or system-dependent recovery. The actual refrigeration system's compressor must be operational. Okay, it uses the system's compressor to move the refrigerant. You basically hook the recovery cylinder up to the discharge side of the compressor. It sucks the refrigerant out and expels it into the recovery cylinder. Again, active recovery, self-contained recovery machines. This is primarily what you're going to use. Passive recovery, system dependent, okay? I think I've used it twice. Uses a systems compressor to move the refrigerant into the recovery machine. Questions on these two, active or passive? Is it pretty clear? Okay, again, active recovery. You're using a standalone recovery machine that has its own compressor to pull the refrigerant out of the system and put it into a recovery cylinder. Passive recovery. You're using the system's compressor itself to move that refrigerant into the recovery cylinder. Big difference between the two. Okay, piercing valves. Piercing valves are valves that we can add to a refrigerant system that doesn't have any access fittings. Okay, so if let's say you have a small little refrigerator, okay, or window unit, these systems do not have access fittings. Okay, they're manufactured, charged, and sealed in a factory. There's absolutely no access fittings in these things, and it's all welded shut, so you have no way to put your gauges on these systems. Okay, when servicing a sealed system, you can't just cut the pipe and let the refrigerant out. You still have to recover it. We use piercing valves for this. Okay, this is an example of a piercing valve. It sits on the pipe, you clamp it down, and then up at the top of this thing, okay, right up here, when you screw this hex screw in, it actually pierces the pipe and allows the refrigerant to come through to this access fitting. Under the cap here, you can put your gauges on it. Okay, so piercing valves are a temporary add-on that we can use to recover or access the refrigerant in a sealed system. These two little extra pieces here are shipped with every piercing valve, and it allows you to use it on a smaller size pipe. Most of them are set up for 3/8 inch pipe, but by using these additional pieces here, you can use it on a 1/4 inch pipe.
Is that pretty common to be using a lot? That seems like it's pretty easy to use.
It's very easy to use. They're common for people who service a lot of appliances. Okay, so people who are doing a lot of refrigeration in terms of either domestic or small bar equipment that might not have access fittings on it. You use these a lot. But they cannot remain in the system, and I think I say that on my next slide. So you're going to use it to recover the refrigerant, okay, because it allows you to clamp onto the line. But piercing valves are temporary. They can't be left on a system. They leak frequently, okay? It is a requirement to install a permanent valve while the system is empty. So in other words, what you're going to do is you're going to put the piercing valve on, recover the refrigerant out of the system, make your repairs, okay, and then while the refrigerant is not in the system, you're going to cut the line where you have the piercing valve installed. Okay, it's a great place to cut it because you can't leave the hole anyways. You're going to cut the line and you'll put in a T with an access fitting in it. Okay, with a Schrader core. Okay, so again, very frequent to use. Okay, I always carry some in my box of parts, always carry some. But they can't be left on the system, they leak. Questions? Okay, now when you guys get back into the shop, whoever your normal instructor, your shop instructor is going to be, okay, they're going to do a demonstration on this. Okay, but I have to run through this or some of the other stuff we talk about is just not going to make sense. Okay, so in the step-by-step process of refrigerant recovery, you're going to get all this equipment together you need, okay? Especially like if your truck is in the parking lot someplace and you're on the roof of a commercial building. Okay, you don't want to make 25 trips up and down the ladder to go get all this stuff. You want to do everything once. Okay, so you're going to have to, of course, have your gauges. You're going to have an extra hose. Okay, you have to have a recovery cylinder. You have to have a scale, and of course you have to have your recovery machine. Okay, by the way, carrying this up the ladder is sometimes very interesting. Safety is paramount to everything you do. A lot of times you're on these jobs by yourself. Okay, so if you're carrying something up a ladder, are you going to carry all this stuff up the ladder at one time?
No.
Yeah, it would probably be a very bad idea to try to carry this all up the ladder at one time. Okay, sometimes the best thing you can do is carry a very long rope where you can go up the ladder. You can have some of the heavier stuff tied to the rope. Okay, and then you rope it up to the roof. Okay, as long as you know how to tie a good knot. Okay, sometimes you can get a building maintenance person to help you. You go up the ladder, they tie everything to the rope one by one, you pull it up. Gauges you can always just toss over your shoulder. Okay, but remember you have your toolkit, you have everything else. So just be very cautious about safety. Okay, once you're on the roof, you have to find the net content of refrigerant that's already in your recovery cylinder. Okay, for those of you taking notes, this formula is very important. Okay, WC is stamped on the outside of every recovery cylinder. Okay, and you have to look closely. You'll find WC. Okay, that stands for weight of contents. WC, weight of contents. You find that number for the WC, okay, and you take that number and you multiply it by 0.8, and you come up with the answer. Okay, that tells you at 80% full, what is the allowable weight? Okay, because you're not allowed to fill a recovery cylinder over 80% full. Okay, because we all know refrigerant expands as it gets warm. So you can't fill a recovery cylinder over 80% full. TW.
I was gonna say, can you give us an example of a weight of content like a general weight of contents, like
29 pounds 5 ounces.
Okay.
Okay.
So then you times that by
0.8. And I'm reaching for my calculator right now because I can't do math in my head to save my life. So.
You said 29?
Yeah, and I would ignore the 0.5, like the 5 ounces. So I would just take 29 times 0.8, which comes up to 23 pounds. 23.2. Yeah. Okay. And then you take the Tare weight. Okay, which again is stamped on the tank. Can anybody tell me what Tare weight is?
Tare weight is the weight of just the refrigerant minus the container.
No, other way around.
Oh, yeah. Weight of the container plus the object.
Okay. Tare weight is the weight of the container only. Did somebody just have a question for me?
Yes, when we were in the shop, I was reading on the side of one of the refrigerant containers a similar formula, but I had sworn there was like one extra step, and it was pretty small and marginal. It worked out, but
do you remember what it was?
I would have to look it up. I can't remember off the top of my head. I think it had something to do with specific gravity.
Oh,
and
maybe.
It wouldn't affect your...
Okay, I'm getting a real echo from your side, but I know what you're talking about. When they do their test, every 5 years we have to have the cylinders tested. Okay, they use a liquid with a specific gravity of 1.
Okay, yeah, I knew the specific gravity would be close to 1, so it wouldn't affect the outcome too much. I was just curious more what the purpose
No,
of it.
I know. Yeah, I now know. Yeah, they use it's for their testing.
Okay.
Okay, so tare weight, okay, is the weight of the cylinder. Now again, that can vary based on different cylinder manufacturers and stuff like that. Okay, so let's say if my cylinder weighs 15 pounds. Okay, so remember, we came up with like 23.2.
22. Yeah, 23.2.
Now, if my cylinder weighs 15 pounds,
38.2.
that basically brings me to 38.2. Okay, now, just to be safe and because I can't stand decimals, I'm going to say 38. Okay, because it's still under that weight. So, I legally cannot fill this cylinder over 38 pounds. Okay, that is my total capacity weight. So when I put this cylinder on the scale, my maximum weight the scale can show is 38 pounds. Okay, this is very important because refrigerants expand when they get hot. Okay, and those cylinders can and do explode. This is a personal safety issue.
Why don't they just put the 38 on the container?
Because every container is slightly different weight. And you really don't know until you, because if you think about it, you really don't know until you get it in the field and actually know what the cylinder weighs. That's the explanation I was given many years ago. Could they do it? Yeah, but they never have.
And let's say that the sticker or whatever that gives you the tare weight is faded or worn off or whatever. How do you have to weigh, like physically weigh the tank?
Well, the problem is that you don't use refrigerant recovery cylinders for every, you don't have a new cylinder for every job, okay? So if you have an empty tank, okay, and it's in a vacuum, we'll talk more about that, but if you have an empty tank that you know is completely empty, yeah, you can toss it on the scale and weigh it. Okay, and you can come up with a tare weight. Would I write that number onto the tank someplace? Oh, yeah. Because once your tank has a little bit of refrigerant in it, you really can't do this calculation anymore in terms of getting a new tare weight. Does that make sense?
Yes.
Okay. But again, this is engraved actually, the WC and the TW is actually engraved into the handle of the cylinder. So it's pretty tough for those just to get worn away in the 5 years before they get tested again.
Well, that's good.
Okay, it's actually engraved in the metal. Okay, that formula is very important, folks. It's actually not just important for the EPA exam, it's important for as you go on in the field. Okay, so your tare weight is at the top. Okay, this, again, your WC weight of content, water capacity, however you want to label it, is down there, WC 47.7. That specific gravity that someone asked me about, again, comes to when they first test it, because water has a specific gravity of 1. Do we know what the specific gravity of all our refrigerants are? Do people carry that on their trucks? No. What's this date up here at the top? There, if you look closely, there's a date there, and I'll erase my pen in a second.
Date of manufacture of the tank.
Yes. Okay. There's another date down here.
The date it was first filled.
No, that's my retest buy date. You consider that a tank expiration date.
So that was expired.
So 1195 was when this tank was manufactured. Okay, the date that's stamped in down here is retest by 11/2000. And again, this is an old picture. Now, some of you folks have probably been through a shop in the shops where we've actually asked you to go look at every single tank in the shop and make sure that our tanks are not expired. I know the guys from York just did this recently. A matter of fact, probably the week before we had to basically close the shops. Because again, every 2 or 3 years, I come through and ask everybody to give me the expiration dates because we change out these tanks. Okay, so again, these dates are important. If you use a tank that's expired and get hurt, OSHA has a real problem with that. Okay, you as the technician have the responsibility to look at tanks. And we have to make sure the expired ones get sent back to the supply house. Okay, do they destroy the tank? No. Okay, it may come out with a line through this test date and a new test date stamped right under it. Because they've said they've tested it, went back to the tank manufacturer, it was tested, it was pressurized, and it was sent out again. Okay, with a new expiration date. Sometimes on some tanks you can see 4 or 5 dates here. Okay. Recovery cylinders come in different sizes. The most frequent sizes you guys will use and carry on trucks in the future are those 2 sizes. If you ever start working in large commercial environments, you may have one of these on a job site. You can't carry it on your truck. It's way too heavy. And if you work in an environment that they have a lot of refrigerant, like frozen food warehouses and stuff like that, you might see a big tank like this, okay? But most often, you guys are using these size tanks down here, okay? And they have different contents. They have different weight of contents allowed, okay? And sometimes you may actually have 2 or 3 of these on your trucks, depending on what type of refrigerant you're working on. Okay, I carry 2 of the larger ones for R22 and 410A, and I carry one of the smaller ones for 409A, because I have a couple customers that I take care of for refrigeration that use a different refrigerant in their systems, and I carry one for that purpose. Okay, I also know some technicians who carry one of the smaller ones that's always empty. Okay, because it's much easier to take into on a roof or into a basement or into a restaurant kitchen, and then they'll transfer it to the appropriate larger tank when they get out of when they leave the building. So I also know some technicians who do that. Okay, you cannot mix refrigerants, so you always want to make sure you have enough blank recovery tanks or recovery cylinders with room in it to recover the refrigerant from the system, and it takes some planning. Okay, so if you have a tank that's like 3 pounds from being full, and you know that tank's 3 pounds from being full in your truck, you better get an extra tank on your truck, because most systems carry more than 3 pounds of refrigerants. So there's an advanced planning. Who's responsible for inventory management on your service van when you get in the field?
You are.
You are.
You are. Okay, and it gets very expensive to take care of technicians who do not properly manage the inventory on their trucks. Sure, the system will tell your dispatcher, oh, he's used up this part and stuff like that, and occasionally they'll have them all sitting there for you. But the end thing is, you're responsible for inventory management. Okay, so we've gathered all our parts. We know what the refrigerant content in our tanks is. The step 2, we connect your gauges to the equipment. The red hose, which is the high side, goes to the high side of the equipment, most awfully on the liquid line. The blue side, the blue hose, which is the low side, goes to the low side of the equipment suction line. And by this point in the course, it should not be any surprise to anybody that the liquid line carries liquid refrigerant. The suction line is a vapor. Okay? Everybody at this point should be very familiar with the refrigerant cycle. Make sure all gauge valves are closed. Okay, do not connect your gauges without making sure the gauge valves are closed, and then double check it when your gauges are installed. Okay, it's critical. Now, when you close your gauge handles, and I know I had a conversation with a few people in shop over this already, but when you close your gauge handles, how tight do you close them?
Finger tight.
Finger tight. Why don't you crank them down?
Because you could break the valve.
Can you get a little bit more specific than just break the valve?
You can wear the threads out on the valve.
There's a rubber gasket. There's a rubber O-ring in all of these, in all of your valves on the gauges. Okay, you can actually tear the rubber if you tighten it down too far. Okay, there's rubber O-rings in them. So just be cautious of that. You don't need to use your bulging arm muscles in order to tighten down the gauges. Okay, don't be He-Man on the gauges. Finger tight, okay? They're not meant to be abused. Connect the recovery machine is the third step. The middle hose, most of your gauges have a yellow hose in the center. The middle hose from your gauge manifold connects to the inlet port of the recovery machine. Okay, additional hose from the recovery machine. This is that spare hose. Okay, additional hose from the recovery machine goes to the liquid side of the recovery cylinder. And I'm going to talk more about cylinders. You'll understand why there's two sides. Now, there are people in the industry who will tell you to put it to the gas side of the recovery cylinder. But you're going to find out you have much better luck if you go to the liquid side. It's all about speed. It will do the same thing. It will get it in the tank, but there's a speed issue. Okay, you want this to take as short a time as possible. So again, you will need an extra hose. Okay? You can get them at supply shops when you start doing a lot of refrigeration. For the purposes of our shops, we have extra hoses in the shops for you guys. Starting from the hoses connected to the equipment. Okay, you have to purge all the air out of the hoses. How do you purge air out of a hose?
Run a liquid through it?
No. You just open it a little, or you basically crack the connection away from the equipment. So if your hoses are connected to the equipment, okay, you're going to, at the gauges, you're just going to loosen very briefly the connection of the hose to the gauge, and you'll get either a little bit of vapor or a little bit of sort of liquid vapor, that type of refrigerant coming out of it. Very tiny bit. It's called a de minimis release. We have to get the air out of the hoses. Okay, you do not want air in your recovery cylinder. Okay, once you get to the gauges, open both side handle, and then the valve that goes to some of your hoses will, and I don't think any of your gauges anymore have a valve on that center line anymore. There's some gauges out there that do have an extra valve. But if you have an extra hose, leave the one closed, okay? Some of the gauges that are out there have a gauge manifold and have 4 hoses coming out of it, okay? Dang, that sort of looks like a spider or something. Okay. Your 2-side one, this is my low side, my high side. This might be an extra one, and then you'll have a small line that's sort of a yellow or something like that that goes to your recovery machine or your vacuum pump. But what we're talking about, if there's an extra hose, do not open the valve on that hose.
Now that extra those manifolds, is that for vacuuming purposes?
So yes, actually it is. Usually when you have an extra hose on the manifold, that hose is a little bit bigger.
Right.
Okay, it's a 5/8 inch hose. It's a little bit bigger than the ones you're using on the other. The large, and I'll talk about this when we talk about vacuuming, but the larger the hose, the better you're going to pull a vacuum. Okay, the gauge hoses that I use normally, I use a standard size hose, okay? But are there occasions where I'd like to have that extra hose? Oh yeah. But the manifolds with the 3 hoses work fine for most cases. Okay, it just spends a little bit longer to put it into the evacuation. At the recovery machine, we turn the inlet valve to on and the discharge valve to on. Then we bleed the air out of the line at the recovery cylinder. Only then do you open the valve on the recovery cylinder. And again, when you get into shop, this is going to be demonstrated to you. Okay, open the valve on the recovery cylinder only after you've bled all the air out of the entire thing. Don't take a shortcut and not bleed the air out. The other very important thing, okay, when you start doing this, the very important thing is the discharge valve of the recovery machine has to be open. If you start the recovery machine without that discharge valve being open by accident, you're rushing, you didn't bleed the air out properly, and you start that recovery machine without the discharge valve being open, you take a real risk of damaging that recovery machine. Okay, because the vapor or the liquid that's being pumped through that recovery machine has to have a place to go. Okay, so by doing the proper bleeding, you're always going to have that discharge valve to the on position. It's very important. Okay, we turn the recovery machine on and we wait until all gauges show 0 psi. Okay, and there's different things in here. You're going to see a couple different numbers as we start going through EPA. We could have 0 psi, we can have 5 inches vacuum. Okay, and then there's some other numbers we're going to talk about as we go through the EPA. But we have to make sure the refrigerant is out of the system. You're going to close all gauges and you're going to wait a few minutes to see if the pressure rises or doesn't rise again. Liquid can get trapped in the oil of the compressor. Okay, and the pressures may go up again. If the pressures go up again, can you ignore it or do you need to recover it?
Recovery?
Yeah, you're going to recover it. You've got to make sure the system is empty. It's important. Once the system is empty, close all gauge handles, purge the recovery machine if the machine needs purged. Turn off the recovery machine, turn off the recovery cylinder valve. Disconnect the recovery cylinder and the machine and put them aside. Weigh the recovery cylinder, record the weight and the net refrigerant recovered. This is now law. You are responsible for every piece of equipment that you work on. You are responsible for recording onto a service ticket or in some sort of log the refrigerant recovered and the refrigerant put into a system. It's part of record keeping. When you disconnect the hoses, the hose between the recovery cylinder and the recovery machine, there's that extra hose. That could have refrigerant in it. Be careful. You cannot, unfortunately, that one hose, you can't get all the refrigerant out of. It's going to have refrigerant in it. Okay, could be liquid, could be totally vapor, but just be aware there might be refrigerant in that hose, so be careful when you disconnect it. It's called a de minimis release. We can't recover any of that, unfortunately. Okay. Recovery rules, as I talked about. Recovered refrigerant cannot change ownership. Has to be reclaimed to change ownership. The refrigerant is the property of the person who owns the equipment. Recovered refrigerant cannot be mixed. Recovery containers, this is very important and shows up on every EPA test. Okay, recovery containers must be DOT, Department of Transportation approved, and color-coded gray with a yellow top. Department of Transportation, as soon as that refrigerant is in that recovery cylinder, the Department of Transportation has jurisdiction over how that refrigerant is transported and shipped. Okay? Because it has oil mixed in it. It can be considered flammable. All newly manufactured recovery and recycling machines has to be certified by an EPA-approved organization to meet the standards. Okay, according to requirements, you're supposed to put every machine into a vacuum before each use. Just make sure the machines are clean. Most of the newer machines don't hold that much refrigerant, but the entire idea is you're not contaminating the refrigerant between systems.
I'm sorry, did you already discuss what the vacuum is?
No, I'm going to get to that. That's not going to be today. That's going to be a couple days down the road.
Okay.
Okay. Just what we do is we put everything into a vacuum. That removes air and removes moisture at a high level. I'll talk much more about the vacuum when we talk about evacuation. Okay. 134A. Okay, 134A has different oil requirements than R22. Okay, back in the day, before we started to use a lot of 410A, you had to carry different recovery equipment for 134A, because 134A oils would break down the gaskets that were being used in the R22 and R12 machines. Now, most of our recovery equipment, most of the machines you will be using, okay, as long as you flush them out with nitrogen, put them under a vacuum and take care of them, pump them down properly, okay, most technicians carry one recovery machine on their trucks, okay, because again, we are mostly using the same oils that 134A use in the other equipment. And again, we just have to be aware that, like when you go from an R22 to a 410A piece of equipment, you do not want to cross-contaminate oils. So you might have to flush out a recovery machine. You might have to throw some nitrogen through it. You might have to put a vacuum pump on it. Okay, recover as much liquid when possible. Most recovery machines will do this on their own. They'll first get the liquid and then the vapor. Okay, liquid recovery is the fastest. Make sure you replace all the caps from the unit and the equipment. Caps on the recovery unit keeps out contaminants. The recovery equipment comes with caps to cap off all the hose connections. Put them back on. Okay, it keeps the system clean, keeps out contaminants, keeps out moisture. Okay, now the system's empty. You can do whatever repair work you need to accomplish. Okay? Do not braze with your gauges on the system. I will repeat that. Do not braze with your gauges on the system. Very important. You braze with your gauges on the system, you're going to melt the gaskets that are in the gauge connections. Okay? Remove any Schrader cores while you're brazing. Again, they have rubber seals that will melt. No one is good enough at brazing that the copper will not spread heat while you're heating it. Okay, the braze has a much higher melting temperature than the rubber seals on these fittings. Okay, so it's very important. Make sure you remove the fittings before you braze. Questions? Any questions? Okay. There's a lot of different recovery and recycling equipment that are out there. Okay, and it's important to actually a little bit know about it. You will not have to worry that much about recycling. I don't know any contractor where the technicians do recycling. We've already talked about the idea of what recovering is. Okay, you cannot purge or vent refrigerant into the atmosphere. It's illegal. Okay, so the whole goal here is to use recovery equipment that will let you safely remove refrigerant from a piece of equipment so it can be repaired or disposed of properly. Key word is safely. Recycling, we talked about recycling. Filters reduce moisture, acid content, foreign material. Okay, again, we're separating the oil because everybody knows oil goes with the refrigerant. Recycling, okay, is normally these days done back at the service shop, okay? Technicians most often don't carry these recycling machines with them.
What do you do with the filters and stuff that you take off? Do you just throw those in the trash, or do they have to go to a specific receptacle for disposal?
If it is filled with oil, it should go into an oil recycling bin, okay? In other words, most shops have an area where oil filters and stuff like that go, and they're picked up and treated by a hazardous waste company. Okay? If they're not full of oil, they can just go into the regular trash. I think a lot of it is a contractor. Does that answer your question?
Yeah, I was just wondering.
Okay. Good contractors will have really good recycling programs, but sometimes doesn't always happen. Okay, in most cases, recovered refrigerant is to return to the system from what it was taken following repair of a system. Recycled refrigerant can be returned to the system as recovered or used in another system belonging to the same owner. Again, even though it's recycled, in other words, we've passed it through filters and everything else, we cannot change ownership. Reclaimed refrigerant is a totally different thing. It's a reprocessing of recovered refrigerant, so it's pure. Okay, HRI-700 is here again, or ARI-700, same thing. Must meet purity standards. Reclaimed refrigerant, okay, can be charged back into a unit designed for use with that refrigerant. Okay, you cannot do this in the field. Okay, it's a manufacturing only. Okay, equipment is divided into 3 categories: recovery system, recovery recycling, and reclaimed systems. Okay, local, state, and EPA rules and regulations must be followed. As we've talked about, follow the equipment manufacturer. Section 608A or 608, this is exactly what we're going to be talking about. Section 608 controls how we handle refrigerants. It's the EPA rules. Okay, it's part of the Clean Air Act. It prohibits venting of refrigerants. Upon determining that system has a leak or a fault in a refrigeration system, a service technician must recover all refrigerant in the unit. Once the issue has been repaired, then the system must be evacuated using a vacuum pump prior to being recharged. We'll talk more about that. When we open equipment for service, the technicians must evacuate the HVAC system to establish vacuum levels. Okay? This is an older style equipment, refrigerant recovery piece of equipment. Okay? It's much faster, much lighter. It's even gotten lighter than this. This is considered a heavy monster by today's standards. Okay? You have your inlet valve, you have your outlet valve, you have an inlet port, you have an outlet port. We have gauges on the unit so we can see what the pressures are right there at the unit, as well as my gauges. Okay, this has a compressor and a condenser. right inside of it. Okay, many of these now are self-purging. They don't anymore have the purge valve, so there's no need to eliminates the need to change the hoses at the end of this process to purge these things. Okay, so a lot of them are now self-purging. All these machines are all CFC, HCFC, and HFC compatible. Tomorrow we're going to talk about what these initials stand for. If you started your readings, you already know. Recovery machines should be used with other instruments such as digital scales to measure the amount of refrigerant removed from a system. Some recovery machines are equipped with automatic vacuum shutoffs and automatic liquid level shutoffs that respond to switches in the recovery cylinders. Okay, so in other words, if they sense that the recovery cylinder is getting too full, they'll automatically shut things off. Okay, but again, it's the more expensive the machine, the more bells and whistles they have. Okay, all recovery machines manufactured after November 15th, 1993 are required to be certified by an EPA-approved organization. Guys, dates like this one are sort of important. Okay, all recovery machines manufactured after November 15th, 1993 are required to be certified by an EPA-approved organization. Okay, if you start making flashcards or some sort of tool like that as you start studying your EPA material, dates are something that you sort of want to take a look at. Don't go nuts with them, but dates like the one that I just showed you, that's sort of important. Change the filter dryer on the recovery machine. Every recovery machine out there has a filter dryer. It's usually on the inlet valve. Okay, it needs to be replaced. We want to remove moisture and contaminants from the refrigerant before it goes through the machine. Occasionally, okay, perform a leak check. Should be checked approximately every 3 months for leaks. How do I do a leak check? How do I do a leak check on a piece of equipment? Anybody?
Pressure test?
Tile would do it. Put it under a nitrogen pressure. Okay, nitrogen. And then use soap bubbles. Tile would do leak checks. Fittings can loosen. Okay, vans have vibration in them. Your service trucks and everything have vibrations. Check them. Tighten up any loose fittings. Okay, if there's an overfill or a high pressure shutoff, make sure it works. Check gauge calibration. If the machine's open to air, everything should read 0. Most recovery machines don't have oil in them anymore. Okay, most of our recovery machines now use oil-less compressors. If your boss gives you an old one because you're the newbie, make sure that there's oil in the thing. Make sure that it's clean. Something you're going to find over time is the cleaner you keep your tools, the better off that they work. Use appropriate cables. And make sure the plug and everything is there. Make sure the grounding pin is on there. It's sort of important. Okay. Refrigerant recycling equipment allows us to clean the machine, clean the refrigerant, get the oil out of it, get the acid out of it. Okay. Most of the time they're at the service shop, if your contractor even has them. Okay, they have to be manufactured to EPA standards. Okay, and they must contain a label that has been certified to comply with AHRI standards 740. This basically talks about recycling refrigerant, is AHRI 740, recycling refrigerant. A single-pass recycling machine processes refrigerant through a filter dryer and uses distillation to separate the oil from the refrigerant. The refrigerant makes one trip through the machine and is stored in a recovery cylinder. Where do we see refrigerant recycling machines most often? Believe it or not, there's another industry we see these in most often.
Mechanic shops.
Yeah. Yep. The
State
automobile industry. Yeah. Automobile industry has been awesome with recovery and recycling. They use recycling much more than just recovery.
Yeah, I was going to say that machine there looks like the ones I use in mechanic shops.
Yes. The automobile industry has far outweighed the HVAC industry on recycling. Now, what's the big difference between the automobile industry and the HVAC industry? Why has it been easier for the automotive industry to do this?
Because everything's self-contained in a vehicle, and they just have to plug that into a compressor.
Yeah, and the fact that the vehicle comes to the shop.
Yeah.
Okay. If you had to carry one of these machines out on your truck and get it onto a roof of a building someplace, that's a different story. In HVAC, we go to the equipment, where in automotive, the equipment comes to us. So that's sort of a big difference. That's why it's been much more effective for them. Also, the weight of the refrigerant. I mean, your car might have a pound and a half of refrigerant in it. When we're talking about split systems, we may have 15 pounds of refrigerant in it. Big difference. A multi-pass recycling machine recirculates the refrigerant through a filter dryer many times and does not distill the oil refrigerant mixture. After a certain amount of times, the refrigerant is transferred to a cylinder. Okay? Refrigerant recycling and recovery machines can operate both in liquid and vapor cycles, so the hoses don't need to be changed out from one side of the system to another. Reclamation of refrigerant, as we've talked about, is processing refrigerant to its original standards. Can only be done through chemical analysis. Okay, it has to remove 100% of the moisture and oil particles. This involves heating the refrigerant, cooling the refrigerant, distillation, whole bunch of processes that you're not going to do in the shop or in the field. Okay, reclaiming is done at a factory. Okay, the refrigerant is introduced in the reclaim system as either a vapor or liquid. Refrigerant is boiled at a high temperature under high pressure. Refrigerant enters the large separator chamber where its velocity is reduced. This allows metal shavings, oil, carbon, and acid to drop to the bottom to be removed. Gravity basically works on here. Okay, it's at a high temperature. Okay, the refrigerant is boiled off. Okay, the distilled vapor passes to an air-cooled condenser and is converted to a liquid. Okay, we remove the moisture as well as microscopic contaminants through a filter dryer. Liquid then passes into onboard storage chambers. With these chambers, an evaporator assembly lowers the liquid temperature. The refrigerant is then transferred to external cylinders. Okay, reclamation companies can also dispose of unwanted refrigerants by incineration. Okay, we burn unwanted refrigerants at least 1200 degrees Fahrenheit. Okay, that gets rid of all the chlorine out of it. It actually incinerates the chlorine. Okay, questions?
Well, so essentially, what they're doing is it's pretty much like a giant still, just for coolant.
Yeah, actually. Don't go build one in your yard and say that that is my refrigerant recovery system.
Yeah, I don't think you get part of that.
Nah, that won't work. Okay. In the course material, okay, and I'm going to point it out because I want everyone to know it's there. In the course material, okay, you have an EPA manual. For those of you who pull PowerPoints down to take notes on, I've given you a couple options here. You will see the PowerPoints that are broken up in the per topic, and okay, in other words, the core, and I'll make the type 1, type 2, type 3 available. Or you will find the full presentation. Personally, I would recommend you do it topic by topic, okay? Try to keep it a little bit separated, okay? This is all I did was for the individual topics, all I did was take the full presentation and break it up into the different classifications, the core, the type 1, the type 2, the type 3. It's all there. But for those of you who want a couple 100-slide PowerPoint, the full one is there as well.
So that's everything you need. That's everything you need to study for this exam.
Basically, yes. You'd have to have this EPA manual, which I'm going to point out a couple things to you in a minute, and you need to either have my individual PowerPoints or the full one. Those are the same, okay? Again, the full one is just before I broke it up into individual sections. That's what you need. Okay, if you're looking at the PowerPoint, you want to look at the notes. Okay, I don't know if you know, but on PowerPoints, there are notes that can be put on every slide. Okay, you'll see the slide notes down at the bottom of the screen. Okay, and they actually direct you to certain places in the manual. Do not try to study everything at one time. Try to keep up with where I'm at in the material. Okay, like tomorrow I'm going to start with core. Don't go nuts trying to read it all at once. You'll fail the exam. Okay, this is the EPA study guide that I currently have on my screen. Okay, it's the 9th edition, version 2. If you have anything else, you do not have the right guide. Okay, these get updated at a time. Now, there's a decent table of contents there. Okay, the prep material is important because it talks about the differences. And this is all part of the exam. They can ask you anything in this manual. Okay, including the introduction. Okay. So overview exam is there. You all want universal. There's nobody on this call that cannot get universal. Okay. I'm going to tell you that right now. There's nobody on this call that cannot get universal. You would have not been able to hand in the work I've already asked of you over this last however many weeks if you could not get universal. It comes down to studying. Okay? When you take your exam, guys, you're going to have to, this is a federal exam, you're going to have a picture ID, okay? And you're going to have to, since we're doing it from remote, as was put in that other documentation I posted, you're going to have to show it so we can record that you showed us your ID. The exam is going to ask you for mailing address, social security number, date of birth, okay? All of this is required to make sure that your certification is properly logged, okay? Refrigerant cycle, by now you guys should know exactly what it is. You guys have seen this before. Okay, matter of fact, I think I used a prior version of this picture. I actually like this one better. But I used a prior version of this picture for a lot of our discussions and PowerPoints and other diagrams we've used. Okay, so all of this is still part of the introduction. You think it's important because they put it in their manual? Yeah. Okay, talks about how to read a temperature pressure chart. You guys already know that because we've already covered it. Okay, so all of this is part of this. Okay, they have some tips for exam taking here. They mention practice exams. Guys, there are practice exams on the website for this company. I will tell you when I want you to take those practice exams. Please don't go in and take those practice exams before I tell you you're ready, because you'll waste the shot at the practice exam. There's only one set of questions. They don't pull from a test bank for those practice exams. Okay? Gives you one full practice exam, but the questions are not necessarily the ones you're going to see on the EPA exam. Please don't waste the shot of the practice exams. follow my directions on this one and take them when I tell you you guys should go take them, okay? I can't force you not to go ahead of time, but it is what it is. I mean, stick with your first answer when you're taking exams. Once you do a lot of studying on this stuff, which I expect everyone to do, your first answer is usually correct. We have actually gone back and checked exams where people have changed their answers, and people have failed these exams because they've gone and changed their answers. Okay? And then you start having core knowledge, which is where we're going to go into tomorrow. My recommendation to everybody, first, get the assignments in that are due today. Okay, get your assignments done. Then, take some time and at least read through the core section of the book. Take a look through it, okay, and take a look before our lesson tomorrow. That way, when we're talking about on a lesson, it will start reinforcing the knowledge that you've got in for the book. I know you guys are on a tight schedule, but those are my recommendations. Anybody have any questions for me?
I got one quick question. The manual that you have on the screen now, is this the same one that you already put in the module?
Yes.
Okay.
Okay, it's in two places. It's number 1 under handouts.
No, I downloaded it. I just wanted to make sure it didn't change because you said it was different. One was different.
Make sure you have the version 2, but I'm pretty sure that's what's in the course. If you don't have the version 2, and it's also at the top of the course. You don't have the version 2, just email me, and I'll make sure that I'll go double check. Okay?
Yeah, it's
no
just
problem.
the 9th edition.
When you go on the first page, it just says 9th edition? Here, hang on one sec. We can resolve this. Hang on one sec. I'm going to put it at the top, guys. I could have sworn I uploaded this already. Bear with me one sec, guys. Let me fix this while I have you on the call. I'll get rid of the old one there. Make sure that one comes up properly. Okay. And I could have sworn, let me look down here. Okay, let me fix this too. Yeah, the version 2 is relatively important because there was some changes made to the rules in the last cycle of EPA stuff. So just grab the version 2. I'll get rid of the old one for you. Nothing major, so if you guys already started doing, you started looking at it already, it's not major changes, but there were some changes. Okay? Yeah, make sure it says version 2. That's the most recent one. I just downloaded that the other day. Questions?
Now I'm just looking in the module now. Does it see?
You might have to refresh.
It's there now, Rob. You just got to refresh it.
All right.
Yeah, it might have to refresh. Okay,
You got to go all the way back to the main menu on the app for the the whole section we're in now for advanced. Refresh that and then go into it.
Yeah, sorry guys, I can't tell you how the app works. I've never used it from a student perspective, so thanks for helping out on that. I appreciate it.